Hello. So today we will be looking at UART transmit and receive all in one. Let's see. So first of all, I found out a way to basically gate control the project on this graphic user interface, the cube ID. So this is the cube ID. Back to the prior video to kind of get a background of why I'm doing what I'm doing, but I'll try to explain it. So if we go here, we can see open PowerShell control. So if we open that, we should be able to select local and local connection type, local connection name, local. That's fine. Then when we open it, you notice that we have PowerShell built in to our Cube IDE. So now I want to change directory to, I believe I have it in C, get, yep, all right, C dot, I believe, yep. So I'm just going to my directory. So then if I go here, I should, okay. So now if I do add, it should work. Check status again. Perfect. Okay. Now I can go ahead and commit my work. Perfect. All right. So that's what I wanted to show. We can manage our version control on the Cube IDE. I don't have to switch between this and VS Studio. All right. Okay. Moving on. So what we want to do today, from the last lecture, we did, I believe we did message received. Okay, so now we want to do both receive and transmit. We will probably get rid of a few code here and keep a few. So let's just go ahead and hit configure the .ioc. All right, we have the IOC. So remember, we already configured our clock and we removed the GPIO. The main thing we are focusing on is this UART configuration. And remember, we want to do both in the same application. So let's go ahead and add. Right now we have RX. Let's go ahead and add another DMA settings, which is transmit. So now we should be able to handle UART both memory to peripheral and peripheral to memory, right? Then let's go to here. We have our DMA interrupts enabled, which is great. So that's pretty much it. Now we go ahead and hit generate code. All right, it looks like we are ready. We'll go ahead and hit open project and we should start seeing blinking in the IDE. Perfect. So our receiving and our transmit is set up. And we want to remove code that might not be applicable here. This will be applicable, so let's leave it here. I really want to do 32 bytes here. That's a typical byte transmission, but for what we are doing, we really don't need 32. Let's keep it to 10. That's fine. Let's keep it to 10. So that when we are looking at it in the graphic user interface, it doesn't feel overwhelming. This, I believe we will still need this. Yeah, I will still need this. So let's keep that. Oh, it looks like we won't be removing a bunch. I initially thought we'll be removing a bunch. We also have, this is DMA initialization. That's fine. We also have this, so we'll probably make a small change. Most of our change will be here. So let's go ahead and define some of the transmissions we want to use. So let's do, one of them will be constant. Let's do factory. factory ID. Let's just do ID. It's okay. Let's do factory ID. Let's do RB 1 2 3 4 5. That's fine. Let's do constant share firmware version. All right, so let's go ahead and do release version dot. So just think of it that we have some values in our MCU, and we want to interrogate those values or grab those values through UART. So this is the two information that we'll be requesting and receiving via UART. All right, so given this, let's check out. So we will still ask, as soon as our code run, we will use UART via DMA to request for data in our buffer. Our buffer is 10 currently, so that's fine. And 1 2 3 4 5 6 7 so 1 2 3 4 5 6 7. Okay, so we should still be good here. Yeah, that's fine. We should still be good here. All right, so this still looks okay, so we'll leave this. So this is the first time we start our program, we receive or check for anything coming from the UART. We probably don't need this, but I will go ahead and keep it there. Then in our callback handler, so if you don't know how we got this callback handler, you might want to go back to the previous lecture, but basically we implemented this callback handler from our driver file. All right, so over here we want to check if this is a UART. Then we want to check the message that is being sent, and this is a C method to compare two characters. That's our buffer. Then I want to compare it with what I am actually sending. So let me copy those really quick. So I will be expecting these two characters here. Control C. So let me go ahead and compare. So essentially, if what is being sent via UART matches this, then I know this is not the best way to go about it, but at least for the lesson. Oh, this needs to be closed out. Let's see. Perfect. All right, let's go back here and perfect. All right, so if that's the case, then we want to transmit let's transmit via DMA, since we already have it, in just in case if it's a large data, but we're talking about 10 bytes of data, so we really don't need DMA if we are being honest. Size of RX buffer. All right, so let's close out of this and we should be good. Let's hold on. Why am I transmitting the buffer? I should be transmitting the factory ID. Man, this does not have IntelliSense. I wish it has a little bit better intent. So I should be transmitting this variable. Control C and Control C. So let's go back here. I should be transmitting a uint 8. Okay, and since this is a character, I don't think size of will work here, so we will use the length of the character, and that should be fine. I'm curious to see else. Let's just put an else here, and I want to just transmit I just want to transmit error unknown command. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So let's change our size of our buffer size. If not, we won't receive all the data. So our buffer size, let's change it to, let's say 18. 18 is fine. So we are and unknown word. Okay, all right, so size of this will be, let's just do the size of this. Let's do 18. I think it was 15. Let's do 15. That's fine. All right, so I guess I can size this up, but I don't need to. You know what, let's do this just for consistency. Okay, so now we should be a little bit consistent in how we handle everything. It's always a good thing to do. It's just warning that the command is not a correct spelling. I think I'm fine with that warning. Then over here we can error message, and then we can consistently make everything look good. All right, perfect. Okay, so let's go ahead and implement the version. We will troubleshoot afterwards if something is off. Control C. All right, perfect. I got carried away. Here we go. Control Z. If you don't know what this is, my clipboard, by the way. So huh, I actually made a mistake here. So this should be factory ID. Okay, let's go through our code real quick. If what if the buffer is huh if what I'm hold on, if I am requesting for factory ID, then I should transmit the factory ID, which is the value in this factory ID, right? Then if the buffer is, and I could just put it here, I don't need to put it in. If, or I could, I think I know. Yeah, let's just do factory ID. Let's just do factory ID. Although typically you will expect to see get factory ID or something like that. But let's leave it as this so that we're not hard coding things. All right, so firmware version, oh, man, I am dropping the balls here. All right, perfect. So if we are receiving factory ID, then we need to send or transmit the factory ID, and the length of the factory ID is this. If we are being asked for the firmware version, then we should transmit the firmware version with the length. Then all other messages that we get, we want to transmit the error message, right? And why do we have this? This is to why do we have this? I don't think we need this anymore. Well, if I transmit this, then I need to receive what I transmitted, right? I don't think I need this actually. If I transmit it, I need to get it back. Yeah, I need to get it back so that I can see it in the console. Yeah, I think I need this. I need this. Yeah. Yep. Okay. All right. Wow, that was a lot. All right, let's go ahead and debug. Let's build first. So if you notice, the perspective is actually currently in debug mode. I don't know why debug became the default perspective, but this is the default. I don't know why. All right, let's just open the C++ perspective, then build. All right, it looks like we have an error somewhere. This right here. All right, let's. It does not like. All right, I think we need to add this in our include statement. Let's go. This IDE is not very great. I'm used to some IDE handling some of these for me. All right, so let's try to build again. All right, so we also have this around this and this. Oh, I'm missing something here. Missing the size of those buffer. I think I should be able to use size of here. Technically will be length of. All right, let's just do that, and let's also do it here. All right, let's build again. All right, voila. All right, so let's go ahead and debug. All right, looks like we are here. All right, perfect. We are in the main loop. All right, so before we continue any further, let's open up our CoolTerm. All right, we want to set up our serial ports to this and go ahead and connect. So let me now go ahead and hit continue. So now we can monitor our 18 buffer size, and also let's monitor our UART. So now we can bring our serial communication, and we want to send ABC. All right, perfect. So we are getting something. So again, I sent ABC. We do not have ABC implemented as a legitimate command, so we are getting error unknown command. So but if we send, and if you notice, we are getting ABCD in our buffer as well. If we send firmware version, I need to add a new line to that. So firmware version is not working. Interesting. Huh. How about factory ID? Unknown error as well. Interesting. It's not working. So we are constantly hitting the error, unknown error. So let's go ahead and debug and see what's going on. So we are obviously getting factory ID. Oh, okay. We are getting some garbage as well. Well, not garbage, but we're not handling for that. So let's send nothing. Let's go back here. Let's send nothing. Let's send clear the buffer. Let's do mem set RX buffer from start to size of buffer RX. All right, so if we clear the buffer, we should be good now. Let's terminate and restart. Actually, I think I will need to hit continue here when we get to the main loop. Alright, perfect. We are in the main loop, so let's do continue and get inside. And all of this is being handled by DMA, which is great. Let's go back here, get this buffer active and get this active. Okay. All right, so now we can send something. Let's send this. All right, let's send. Oh, I'm cleaning the buffer every single time. That's probably not a good implementation, but let's say, huh. Nothing is even showing up in our buffer. Okay. Alright, so factory ID, and buffer is I think I found the issue. This should actually be the same thing. And actually I can just do get ID, so it's easier for me. It has to be the same value, but what I was passing is the get ID. It's okay, we'll just do get ID. And we can pass and get ID. So that's about 6 bytes. I'll just do 6. Then here will be get firmware. And that will also be 6. Okay, let's try again. Continue. Now let's go ahead and hit get ID. Alright, so now our buffer is get ID and our value is get ID. Let's do F5. Perfect, finally. Oh my gosh. Okay, so now let's pull up this and let's pull up this, and we should be able to hit continue here, and we should see our factory ID here. Perfect. Alright, let's remove all these breakpoints. That's enough debugging for the day. So if we send, and let's look at this as well, see how it does interact. Okay, let's come back here. If we do get ID, then if we do get firmware, and we're getting firmware, then if we do get magic, it shouldn't, we don't have it implemented, so it should be error. Yep, perfect. Ooh, that's pretty much the video today. I took a little bit longer because of all the debugging, but yeah, looks really good. All right, I'll talk to you later. I'll be making more, so subscribe if you want to get a notification for when I post. Thank you. Bye bye.